Let's do this question, students. The values of m for which x squared negative 2mx positive m squared negative 1 is equal to 0 as both its roots such that one root is greater than negative 2 and the other is less than 4, and we've been given the choice for m. The choice for m is the value of m lies between negative 2 and 0. Our choice 2 is it m greater than 3? Choice 3 is it between negative 1 and 3? Choice 4 is between 1 and 4. Right? Now let's start this question. We are given, this is what is given, x squared negative 2mx positive m squared negative 1 is equal to 0. The value of a is greater than 0. That's important observation. Now we are expected to locate the values of m for which the roots lie between negative 2 and 4. So one root is greater than negative 2 and the other root is lesser than positive 4. So the roots are actually lying over here, right? And the requirement is that we locate the value of m. In fact, we are expected to locate that interval. Now there are a few things we can outrightly confirm. That is, the value of d is greater than 0 because the roots are real and distinct, right? That's an observation. Number 2 is the vertex, or I should say the axis of symmetry. The axis of symmetry will be the line that has to go in between the parabola, right? And that is given as minus b over 2 times a. So minus b in this case is going to be negative of negative 2 times m. My a is 1. So if my a is 1 and my value of b is present there, this is going to give me the value of m. Right, this is going to be the value of m, and clearly this m should lie between negative 2 and 4, right? Clearly this m should lie between negative 2 and 4. Right, see, that is the understanding. In fact, that is the inferences that we get, right, from the graph, from the very picturization. Now, how are we going to get the value of m? Now, for that, it's very simple. What you need to do is you need to get the value of f of negative 2 and the value of f of 4. So case 1 is when you have a times f of minus 2. A is positive, f of minus 2 is also positive, so this is going to be greater than 0. That is the case that we will get here. And since we know the coefficient of a is 1, it's okay that we find the value of f of minus 2. Substitute the value here. So it's going to be negative 2 squared, negative 2 times negative 2 positive of negative 2 squared negative 1. This is equal to 4 negative negative positive 4m and positive 4, negative 1. So this is going to give me 3, positive 4. Apparently, so this is going to be giving me f of minus 2 is equal to negative 2 raised to the power of 2, negative 2 times negative 2, positive m squared negative 1 is going to be 4, negative positive 4m, positive m squared negative 1. You add this together, you get m squared positive 4m positive 3. But a times f of minus 2 is greater than 0. So this would mean 1 multiplied with m squared positive 4m positive 3 is greater than 0. Now if you were to factorize this, this would give us m positive 3 times m positive 1 is greater than 0, right? Now what is the outcome of this inequality? This would mean m is equal to negative 3, m is equal to negative 1, and we are looking into values towards the right and values towards the left, right? Because of the very fact that m positive 3 times m positive 1 is greater than 0. Of course, this side will produce me positive values, this segment would give me negative, this segment would give me positive. So we are looking for all values towards the right of negative 1 and all values towards the left of negative 3. So that is for case 1. Now having got that, let me go on to get case 2. Case 2 is a times f of 4 is greater than 0. So f of x is x squared negative 2 times mx positive m squared negative 1, and f of 4 is going to be 16 negative 2 times m times 4 positive m squared negative 1. This is 16 negative 8m positive m squared negative 1, and you can rewrite this as m squared negative 8m positive 15, right? If you factorize this, this is going to be m minus 3 and m negative 5, and this is greater than 0. So if you were to draw this, this is 3, this is 5, it's greater than 0, all values on to the left and all values to the right. So values to the right of 5, values to the left of 5. So this is what we have got. Now we have to club these two together to get the value for m, interval for m, right? Now according to the question, we are looking for values between negative 2 and the positive 4, and you have negative 3, so this is negative 2, negative 3 is going to be over here, this is negative 1 and 0, and you got a value 3. So if this is 1 and this is 2 and this is 3, let us take this to be as 5. So this is an important line which we need to mark. We will mark that first. So after we have marked it, this is negative 3 to negative 1. So negative 3 all values, so to negative 1, and if I were to draw this like this, say for example, let me stretch from negative 1 to it goes all the way, right? That's the meaning of this. From here it starts, it moves up to the right side of negative 1. In this case it moves up towards the left side of negative 3. So that's for the first case. In this case 3, so if I were to move up like this goes like this, and 5 move up like this goes like that. Okay, now where is our boundary? So this is our boundary and this is another boundary, right? So now we are expected to look for the intersection of all the values. Now if you can clearly see, there is a -1 here, right? -1 is present from here and then it moves, and there is a intersection of -1 with +3, right? So this is the intersection that we are looking for, and apparently this intersection is lying between -2 and +4. If you were to, we can't take in these values because there is 5 is out of the bound, right? 4 is over here, 5 is out of the bound, and as far as the 3 is concerned, 3 is inside the bound, and it is basically intersecting with the values from -1. So this is the region that we need to look into, or I should say the values for which m holds good. So that would be -1 less than m less than 3, -1 less than m less than 3. So the m is actually lying between -1 and -3. And if you were to take the values of m between -1 and -3, see, this is the equation given, right? X squared -2 times mx positive m squared -1 is equal to 0, right? Now if I were to take, say, m is equal to 0, if m is equal to 0, then what happens here? This goes off, so I get x squared -1 is equal to 0, which means x squared is equal to 1. Therefore x is equal to -1 or +1, right? That is the understanding that we get, because in fact from here I can rewrite this as x -1 times x +1 is equal to 0, which in turn would lead me to -1 and +1 values. Now the question is or are these roots -1 and +1, do they lie between -2 and 4? Yeah, -1 is over here and +1 is over here. So for this value of m which I've taken, clearly I can see that the roots are lying between -2, it's greater than -2, but it is less than +4. You can check other values also. If you were to take m is equal to 1, the same will be true. If I were to take the value for m is equal to 1, this is going to give me x squared -x positive m is equal to 1, right? +1 -1 goes away, so you get 0 is equal to 0. This is nothing but x of x minus 1 is equal to 0. So x is equal to 0 is a root, and x is equal to +1 is a root. So 0 is greater than -2, but 1 is less than 4. So this is the answer.